Good day to all of you. My name is James A. Dawe, and in this video, I will be discussing the rate of energy transfer by sinusoidal waves on strings. So let's proceed to the next slide. So the rate of energy transfer by sinusoidal waves on strings refers to the speed at which energy is conveyed through a string as a result of sinusoidal or periodic disturbance. In the context of waves on strings, such as those produced by plucking a guitar string, the energy transfer is characterized by the wave's frequency and amplitude. The rate of energy transfer is dynamic, so it influenced by factors like tension in the string and the medium through which the wave travels. So understanding the rate of energy transfer is crucial in various applications, including music and telecommunications, where the efficient transmission of energy through waves on strings play a significant role in signal qual- quality and overall performance. So waves transport energy through a medium as they propagate. So for example, suppose an object is hanging on a string and a pulse is sent down the string. So next slide. Um, the pulse lifts the block, increasing the gravitational potential energy of the block Earth system. So a pulse travels to the right on stretched string, carrying energy with it. The energy of the pulse arrives at the hanging block. So let's picture a wave traveling on the string. Like when you pluck a guitar string, imagine someone at one end of the string is moving it up and down, creating a disturbance. The movement sends energy into the strings, making the wave travel. So now let's zoom in on tiny part of the strings. A little piece with length dx and mass dm. This small section is moving up and down in a simple rhythmic way, just like when you see a water wave moving along the surface. To make sense of what's happening, we think of this little piece at if it's on a tiny swings, going up and down in a harmonic way. It means it has a regular back and forth motion in the vertical direction. Let's call it Y. So all of these tiny sections along the strings are doing the same dance. They have the same frequency and move with the same amplitude. Now, we want to understand the energy associated with each of these moving bits. We use a formula that calculates kinetic energy, K, for a moving particle. When we apply this formula to our little piece of the string, the kinetic energy dk linked to its up and down motion is given by, so next slide, dk is equal to 1 half, um, open parenthesis dm, close parenthesis. So when by is the transverse speed of element, if u is the mass per unit length of the string, the mass dm of the element of length dx is equal to u dx. Hence, we can express the kinetic energy of an element of the string as, next slide, this formula. Let's substitute the general transverse speed of element into the equation. So, let's proceed. If we take a snapshot of the wave at time t50, the kinetic energy of a given element. This is the procedure of it. So, next slide. Integrating this expression over all the string element is in a wavelength of the wave gives the total kinetic energy K in one wavelength. So, the sum is this. In addition to the kinetic energy, there is potential energy associated with each element of the string due to its displacement from the equilibrium position and restoring force from neighboring elements. A similar analysis to that above for the total potential energy U in one wavelength gives exactly the same result. This is the result. So the total energy in one wavelength of the wave is the sum of potential and kinetic energies. So this is it. As the wave moves along the string, this amount of energy past a given point on the string during a time interval of one period of the oscillation. Therefore, the power P or rate of energy transfer T sub mw associated with the mechanical waves. So then the equation that shows the rate of energy transferred by a sinusoidal wave on a string is proportional to A, the square root of frequency, B, the square root of amplitude, and letter C, the wave speed. In fact, the rate of energy transfer in any sinusoidal wave is proportional to to the square of the angular frequency and to the square of amplitude. So overall, this is the rate of rate of energy transfer by sinusoidal on strings. So thank you for listening.